right, class. So today we're going to look at direct and inverse variation. Just some review of what we've already talked about and learned, but we'll have this nice chart that has everything in one place, and we'll go over some examples. And then y'all will have an open note test next class period. So these notes that you're taking today, make sure you have them and your other notes that we took before the SOL for next class period for the test. All right? So we're going to go through and just compare and contrast direct and inverse variation and look at some examples and the formulas and all of that stuff. So first, we have our definitions. We have direct variation, which is a set of ordered pairs with a constant ratio. And so remember, a ratio is going to be a fraction, or you can think of it as dividing. And then inverse variation is a set of ordered pairs with a constant product. And when we think of product in math, we think of multiplying. All right, so we're definitely going to use these definitions whenever we're talking about solving and determining if we have direct or inverse variation. The keys to both of these definitions is that we're looking at the ratio of ordered pairs, or we're looking at the product of ordered pairs. So remember, an ordered pair is an xy coordinate. So that's an ordered pair. XY are ordered pairs. Okay, so next we have the equation form of both of these. So maybe you saw some questions like this on the SOL and you needed the equations. You definitely will need the equations on the test, but again, you don't have to have them memorized. You will be able to use your notes. So the equation for direct variation is y equals k times x. In this case, k is a constant. So k is going to be a number, it can be a fraction, but k is a constant, x and y will be our variables. I'm just giving you all a little extra time to write things. I know sometimes I go fast in these videos. Feel free to anytime pause me, or in YouTube you can go into the settings and change the speed of the video if you need to slow it down some. Next we have inverse variation. The equation for inverse variation is y equals k divided by x. Again, k is a constant for that equation. So if you notice, direct variation in the definition, it said a ratio, but if we look at this equation, we were multiplying. The thing here is we wanted, for the definition, it says the ratio of ordered pairs, so that would be us comparing y and x. So if I wanted to get k all by itself, I'm going to divide by x, and then notice there's our ratio, y divided by x. We're going to look at that in one more second after we get a couple of examples. So some examples of direct variation. We might have the equation y equals negative 3x. We could have y equals 1/2 x. Or we could even have y equals maybe x divided by 7. Because another way you can write this looks like y equals 1/7 x. So notice you can write that fraction as the number just being on the bottom, or you can write it as a fraction times x. So those are examples of direct variation. Then we have inverse variation. So for inverse variation, some examples, we want k on top of x. So we might have y equals 24 divided by x, y equals maybe like negative 7 divided by x. You could even have something like this, x times y equals 12. For this one, if we solve for y, we would be dividing by x. So this equation would really be y equals 12 divided by x. So notice it does look the same. So anytime for both of these, you want to solve for y to get y by itself. So we've got definitions, the equations, some examples, and now how to test for it. So how to test for it, this is really when we're using the definitions of those words. Okay, so how to test for direct variation, you're going to take your ordered pairs and you're going to divide every single y by their x. Okay, so you want to check your ordered pairs. Y divided by x, and this is what k equals. So this is our constant. And you're going to check y equals x, y divided by x, sorry, for all ordered pairs. All right, and then for inverse, we're going to do the opposite. So instead of dividing, we're going to multiply. We're going to check y times x for all ordered pairs. So one we're dividing, one we're multiplying. Then we have the graphs. Go ahead, draw in your x and y coordinate planes. Sorry, I should have done that for y'all. Let's just add one in here. So I think a lot of us will remember this. For direct variation, remember your line must go through the point 0, 0, and you're going to have a linear graph. Okay, so must go through the origin. And must be a line. Okay. And then for inverse variation, remember we have the curve in the top right quadrant and a curve in the bottom left quadrant. So to give you a name, this is called a hyperbola. Instead of a parabola, it's a hyperbola. The big thing that we need to realize is that it's never crosses x or y axis. So those will be the two graphs we need to identify. And then lastly, how to solve for missing values. So whenever we learned this the first time, I think we made it a little bit more complicated than it needs to be. So basically, all we have to do when we have direct variation is we're going to set up a proportion. So we'll have y divided by x equals y divided by x. We'd cross multiply and solve. Okay, so this proportion goes back to the how do I test for it. How do I test for it? We're dividing. So we need to set up two things and set them equal to each other by dividing. Okay, so then maybe we can guess the setup for inverse variation is going to be multiplying. We'll say x times y equals x times y. Again, going back to the how do you test for it, we multiply there, so that's going to be the setup to solve for missing value. Okay, so those are all of the notes just in one place. If you flip over to the back of this here, you'll see this 2 columns with direct and inverse variation. You'll work on this activity at the end of class. You'll get this from the substitute. It's going to be a colorful sheet of paper. You'll cut out all these examples and you'll move them to the correct side. So if you thought that this graph was direct variation, we'll move it over here. And then maybe this table is inverse variation, so we'll move it here. So you'll cut out everything, move them around, and you can glue them down. I've got glue in the front. You can also check your answers in Google Classroom. The answer key is in there before you glue them down if you wanted to check. Okay, but you'll do that after you finish taking the notes on the word process. So, word problems. We should have our second page. One side is inverse variation, the other side is direct variation. So, for direct variation. We'll go through these problems. Hopefully we recognize some of them or we're able to figure them out. So number one, you want to draw a graph that has direct variation. The first thing we always do, a point at 0, 0, and then draw a line with a constant slope. There's mine. Yours can look like anything as long as it goes through 0, 0 and has a constant slope. Maybe get the person next to you to check to make sure that you did that one correctly. Number two, we want to write the equation of variation for the graph given. Okay, so direct variation, if you look back at your notes, we have two equations. Y equals k times x. That's our direct variation equation. And then if we wanted to solve for k, we know that k equals y divided by x. So this is our equation. And the second one is how we test for direct variation. So looking at 2, we just need to find the k. If you remember from last time we looked at these notes, we know that k is also slope of the line. So I just need to look at the slope of this line and plug that in for k. So it looks like I'm going up 2 to the right 1, up 2 to the right 1. So our slope would be 2, and our equation would be y equals 2x. All right, number 3. Given y varies directly as x, and the constant of variation is 3, that's our k, list 3 points that lie on the line. So the first thing you want to do is write the equation of variation. So that would just be y equals 3 times x. We just plugged in our k. So now we want to figure out points that are on this line. Well, it's direct variation. We can draw a table to help us figure out some points. I know 0, 0 is always on my line of direct variation. So there's one option. Then you can pick whatever you want. Maybe you do -1 and +1. Maybe you do -5, +5. Maybe you do 7 and 17. Does not matter, but just choose 2 x values and you'll plug them in. So, plugging in, y equals 3 times -1. So that was -3. And then 3 times 1 is 3. So we have our 3 points. -1, -3, 0, 0, and 1, 3. Again, you can get different points depending on the x values you choose. All right, number 4. Assume that x and y vary directly. Write the direct variation equation when x equals 2 and y equals 10. So we know we would have 10 equals k times 2. We want to equal y equals k times x. So I need to find this value of k. So I'm going to solve for k here. So I divide by 2 on the right and 2 on the left. So k equals 5. Okay, so what happened here is I plugged in the 2 for my x and the 10 for this y. Solve for k, and our equation will be y equals 5x. Go down 4 more. So number 5, it says assume that x and y vary directly. Write the direct variation equation given the table. So this is direct variation. To find k, we want y divided by x. So literally choose any of the points you want. There's a point. Here's a point. Okay, choose any point and we're going to divide. I like the second point the best. I can do that all in my head easy. 140 divided by 20 is 7. So my equation y equals 7x. The last three, or well, no, 6 and 7 are two examples where we're finding a missing value. So we're going to use our notes and look at that last row for the missing value setup equations. So for number 6, assume that x and y vary directly. If y is 6 and x is 21, find x when y is 9. So this is direct variation, so we want to set up a proportion. Y divided by x equals y divided by x. You can also write x divided by y equals x divided by y if you wanted. Just make sure you're consistent in what you're doing and you'll be okay. You'll cross multiply and solve for the missing variable. Since in our notes we wrote y divided by x equals y divided by x, that's how I'm going to set up this proportion. 6 divided by 21 equals 9 divided by x. So that's y divided by x equals y divided by x. Now we cross multiply. 6 times x is 6x. 9 times 21 is 189. Divide both sides, and x will equal 31.5. So we set up a proportion and cross multiply. Number 7 is going to be similar, but instead of just having a small word problem, we've got a real world word problem. Try saying that 3 times fast. Real world word problem. Real world problem. Real world. It's hard. That'll be your homework. Try saying that 3 times fast. Anyways, okay, we have the number of shares varies directly with the number of dividends received per year. So before we keep reading, remember this is always y varies directly as x. So we know y is going to be shares. X is going to be dividends received. Dividends also is just money. All right, that's how much you're getting paid back. So it says if Kim owns 5 shares of stock and receives $12 per year, how many shares of stock will she need to receive $24? So we've got y and x, a y and an x. Shares are 5. The money she's getting is 12. So that's y divided by x. And that's going to equal, we don't know how many shares, divided by $24. You can cross multiply. And that would be 120 equals 12y. Divide by 12. Y equals 10. So she would need 10 shares to get $24 back in dividends. Okay, now last direct variation. The gallons of water used to take a shower varies directly with the number of minutes in the shower. So gallons, minutes. Gallons are y. Minutes are x. If an 8-minute shower, that goes on the bottom, uses 48 gallons of water, find the constant variation. So all we're going to do is 48 divided by 8, which is 6. So this means that you use 6 gallons of water per minute. So we just did y divided by x to get the constant of variation k. So those are our direct variation problems. Going to the back, we've got inverse variation. A lot of these problems are similar to direct variation, but instead of using our direct variation equations, we just want to use inverse variation. So inverse variation is y equals k divided by x, and k equals x times y. Okay, so I would say try working these first four by yourself. Pause the video and see what you can do on your own. I'll write in the answers and you can just check yourself, but pause it and see what you get. All right, so here are the answers. We've got number 1, our graph. Make sure it's not crossing the x or y axis. It does not go through the origin. It's a hyperbola. Number 2, that really should have said, I guess, select each equation, table, or graph that represents the inverse variation. So you have 3 out of the 4. Y equals 3, that's direct variation, so that is not an answer. Number 3, we want to write your equation, set up a table, and solve. Choose your own x values or inputs to get your outputs, your y's. And then 4, you're setting up an equation by plugging in the x and the y given, solving for k, and then plugging the k in back to your original equation. So you would have y equals 20 divided by x. And then our last 4, again, are similar to the front, but instead of solving for direct, we're going to use inverse variation. So we want our equations to be y equals k divided by x, and we want k to equal x times y. So number 5, assume that x and y vary inversely. Maybe go ahead and pause these and work on these by yourself too. So we're going to want to write an equation, and then our setup for anything else to find k, you're going to multiply x times y, or if you're looking for a missing value, we're going to have x times y equals x times y. So use those 3 pieces of information. Go ahead, pause the video, and try and work through these on your own. So in number 5, we want to find, this is assume that x and y vary inversely, and write the inverse variation equation given the table. So you first want to find k. All we have to do to find k is multiply x and y, and then plug that in. So all of that is x times y equals negative 24. So you just plug in the negative 24 to k. For 6, 7, and 8, we're just setting up our setup for inverse variation. So if you look back at the original page that I gave you, the notes, you'll find our setup is just x times y equals x times y. So in number 6, assume that x and y vary inversely. If y equals 4 and x equals 14, find x when y is 8. So we're going to say 4 times 14 equals 8 times x. X times y equals y times x. That'll be 56 equals 8x. X equals 7. So notice, these are not proportions. We're setting up multiplication. We're not cross-multiplying. We're just saying x times y equals x times y. All right, 7. Time traveling varies inversely with the average speed. If a train travels between 2 cities in 3 hours at an average speed of 65 miles per hour, how long would it take at an average speed of 78 miles per hour? So again, varies inversely. We're going to say x times y equals x times y. So 3 times 65 equals x times 78. Well, that's 195 equals 78x. Divide both sides by 78. X equals 2.5. That's looking at hours. So that's 2 hours and 30 minutes. And then, last but not least, another setup. We just want x times y equals x times y. So we would have 4 times 18 equals x times 8. 72 equals 8x. X will equal 9. So hopefully you pause that video, set these up on your own. All you have to do is multiply both sides, divide to get our answer. Those are all the notes called the example problems. Please bring these to class on Friday. Friday will be your open note direct and inverse variation test. If you are going to the Hershey Park field trip, we'll get your test rescheduled. Otherwise, plan to have that Friday during class. I will be here Friday. We'll have time to review beforehand because it is a short test, 24 points, since we're taking it on Friday the 24th. Not really, that just worked out. Anyways, I'll review questions beforehand. If you need to come to school Thursday in the morning, I will be here. Remember, Thursday, tomorrow, you have your SOL, science SOL, we're in class periods. But I plan to see you Friday during class to take the open note direct and inverse variation test. See y'all then. Hope y'all are having a great Wednesday. Only 12 more days left of school. You can do it.